Hi, welcome to Mathematics with Tom. I am Tom, and today we're going to continue our journey in the chapter 2.2 of our text by Gilbert Strang, and we're going to take a look at the graphs of e to the it and e to the minus it, and let's put a little piece in there where t is going to be in radians. It's like pi. T is in radians. So here we go. Let's do this. I'm going to help us out a little bit. Let's turn on our grid, and I'm going to graph this. And I kind of know ahead of time how this will look. So I'm going to premeditate this. Okay, here's my complex plane. Remember that we have the real part as the horizontal axis, and our imaginary part is on the vertical axis. And I'm going to do this. So let's start. We're going to graph e to the, let's give it a name. Let's call this our function. We'll call it z of t. So remember, we use z to represent a complex number. For example, like z could be e to the I alpha, or it could be a plus bi or ib. But this time we're going to let z be a function and see how this works out. So z of t, we're going to say this is e to the it. Okay, now before we get started, well, let's think about this. Remember, we can work with e to the it, but we can also work with it in its other form is cosine of t plus I times the sine of t. All right, what I would like to do is this. So notice here the modulus on this is 1. So let's do it this way. If I could write this as 1 times e to the it. Or I could write this, what I wrote down below, I could write this as 1 times cosine of t plus I sine of t. Well, remember that a complex number in polar form is just an angle with its modulus. Its modulus is 1, so we're going to be looking at the unit circle. So let me put a unit circle in place here for us. This is going to be my unit circle. It's kind of wiggly looking, but we can straighten that out with the wonders of these graphing drawing apps. That is a pretty nice unit circle. So let's work with that. I'd like to try a few values. The easiest value is 0. So let's start when t is 0. So let's find z. And we're going to graph these as we go. So let's find z of 0. So z of 0, this is going to be the cosine of 0 plus I times the sine of 0. Well, I'm going to write this. The cosine of 0 is 1. The sine of 0 is 0, but I'm going to keep track of it and write it as 0i. Usually see it like that. So let's graph that. And let's graph a few more. I'll graph that with this pretty blue. So that would go about there. That's not going to work very well. So let's do this pink or red. Red's pretty. So there, that would be z of 0. Okay, let's try another one. How about z of, let's try pi over 4. Well, that's going to be the cosine of pi over 4 plus I times the sine of pi over 4. Well, this is equal to the 1 over the square root of 2 plus I times 1 over the square root of 2. Oh, yeah, that is very simply going to just give us, where'd my pink go? Right there. This is going to be this line that just comes out here, pi over 4, and it has sides of root 2 over 2. This is my point, z of pi over 4. Let's try try a couple more just to make sure we have this pattern. Z of, let's try pi over 2. Well, that's going to be the cosine pi over 2 plus I times the sine of pi over 2. Well, that's the cosine of pi over 2 is 0, plus the sine of pi over 2 is 1, so this is going to be a 1i. And look at where we end up. We're at 0 plus 1i. That is this point right there. That is z of pi over 2. Wait a minute. If you look at it, it looks like we're mapping our way, if you will, around the unit circle in the counterclockwise or some anti-clockwise direction. Let's just try one more, I think, to confirm this. Let's try z of pi. Well, that's going to be cosine of pi plus I sine of pi. Well, cosine of pi is going to be a minus 1. Sine of pi is 0. This is 0i. That will put us all the way onto the other side of the unit circle. That is z of pi. And you can see, so here's what we have. And z of t equals e to the it, then the graph is the unit circle in the clockwise direction, or counterclockwise direction. Oops. Okay, and you might expect it. I would encourage you to try this yourself, but maybe we'll call it z1 of t, maybe another function, a complex function. If it's e to the minus it, then we have the unit circle. In the clockwise direction. Now, let's put all this together. Here's how we do this. So I'm going to grab a new page. We're going to keep all of that locked steadily into your mind, or maybe keep it close in your notes. And let's take a look at how this comes together. The best way to do this is we're going to consider this. What if we have this problem that we haven't even had it really talked about yet? But what if our problem was this? Solve y double prime plus 2y prime plus 2y equals 0. Okay. This is kind of an interesting problem, and the only way we know how to solve this at this point would be with undetermined coefficients. So let's try that. So we're going to try some null solution. Well, there's only a null solution, so we'll just write y equals e to the I. Oh, whoops, we don't know what it's going to be. We just want to know e to the what? E to the st. We have to figure out now what s will be. So let's substitute that in there. Remember, we're going to need a second derivative, y double prime. I'm going to turn this off for a sec. We're going to need y prime. So in this case, y prime is going to be s e to the st, and we'll need y double prime. So y double prime is going to be s squared e to the st. Okay, let's solve this equation. Well, when I plug all this in here, I'm going to get an s squared e to the st plus 2 times s e to the st plus 2 times e to the st equals 0. I'm going to factor this out, so you could think of this as s squared plus 2 times s plus 2 times e to the st equals 0. And we know that e to the st t is not 0, so that implies then that s squared plus 2 times s plus 2 has to equal 0. Now, if this factored, I promise I would take you down that route, but it doesn't. So I'm going to solve this using the quadratic formula. So that's just s equals, remember it's the negative b, so it's going to be a minus 2. Then I'm going to have plus or minus the square root of, and then we're going to have it's going to be a b squared, so that's 4, minus 4 times a, which is 1, times c, which is 2, so that's going to be 8. You should double check that arithmetic of mine. Now let's simplify this. So we can simplify this as negative 2 plus or minus, well, 4 minus 8 is minus 4. The square root of minus 4 is 2i. So plus or minus 2i over 2. I could factor a 2 out of the numerator. It'll cancel with the 2 in the denominator. And I'm left with this answer of minus 1 plus, I'm going to write both answers, plus I. And my other answer is going to be minus 1 minus I. Those are, so I have 2 solutions. For this, let's just take a look at one of those solutions. So our solution is e is, whoops, it's y, is y of t is equal to e raised to the minus 1 plus I times t. Okay, now you might think, I don't even know how to graph this. And that would be a natural reaction to this. But we do. And that's the wonderful thing. We just need to be shown. Watch this. If we write this as e, we distribute the t. This would be a minus 1t plus it. But remember, that just says that those exponents are being added. And in an exponential, this is the same as e to the minus t times e to the it. Look at what we have. We have just written this as an exponential, a real valued exponential, times the complex valued exponential. Well, wow. What is that? Look at what this is. This first piece right here, or not this, that's the second piece, clearly. This first piece right here, this is the modulus. This is the modulus. Now, modulus, this is the modulus of y, of t. So, whoa, what does that mean? Yes, the modulus can actually change over time. And then what do we have here? Well, e to the it, we just took a look at this. What is this? This is just a graph that travels the unit circle. That's just the unit circle. So we can, let's take a look at and graph this. It's really clever how this comes together. I'm going to pull up some graph paper. I'm going to make a nice pretty graph for us again. So there's my graph. And I probably should have made it bigger, but I think this will work. So again, we have the real component, and we have our imaginary component. And notice this. So here we go. We're going to have to plot some points very carefully. And remember that t is in radians. I know when someone asks us how much time has passed, we rarely say, oh, well, we've just passed pi over 2 radians, but it works. It would be a completely reasonable number to use. If your friends aren't mathematicians, they'll not be very appreciative of your humor, but we're going to work that way. So let's try this. Let's try y of 0. Well, y of 0, this is going to be e to the 0 minus 0 times e to the I 0. Well, that's just 1. That's just 1. We know that's 1, so let's just put a dot at 1. Let's just put a dot at 1. And actually, before I do that, I'm going to graph my unit circle. Here's my unit circle. I'll put this on here. But that's not the graph of my function yet. I want to do this as a guideline. So let's graph another one. What about, or find a few values and then we'll graph these. What about y of pi over 4? Well, let's do pi over 2. We only need a few. Pi over 2. Well, this is going to be e to the minus pi over 2 times, well, we already figured out what e raised to the pi over 2 was. We said that was 0 plus 1i. And then let's try another one. What about y of pi? Well, this is going to be e to the minus pi times, well, here we said this was 1 plus 0i. And we can try, let's try one more. Let's try y of 3 pi over 2. Notice we're almost gone in a circle. That would be e to the minus 3 pi over 2 times, well, that's going to put us, that the unit circle part, let's try it. Oh, I won't go too fast. This is the cosine of 3 pi. I'm just expanding out e. Let me write all of that. Sorry. I got excited. It's going a little fast. So this is going to be e I to the minus 3 pi over 2. Well, this is e to the minus 3 pi over 2. And then if we expand the complex exponential, this becomes cosine 3 pi over 2 plus I sine 3 pi over 2. But what is this? This is e to the minus 3 pi over 2 times, well, times the cosine here is 0. So this is going to be 0 plus sine here is minus 1. So this is going to be plus, I'm going to make it a minus 1i. All right, I think we have enough. Let's graph these points now. So our first point that we had was 1. So we started right here at 1. Now, from there then, the next point at pi over 2, time was pi over 2, we were actually, well, if we didn't have this modulus, we would be here, a little x. But we're not. Because what happened? Well, we're being multiplied by a number. Well, e to the minus pi over 2 is going to be less than 1. Actually, it's a lot less, but for the sake of illustration, I'm going to put it maybe here. That right there, this length here, this modulus now, is e to the minus pi over 2. That's the modulus there. Well, now what happens? Now our next point is e to the minus pi, 1 plus 0i. Well, 1 plus 0i would be out here. But our modulus has continued to shrink. So now the modulus right here, this modulus, is e to the minus pi, which is actually much smaller than that, but for the sake of illustration. Well, our next one was y of 3 pi over 2. Well, if my modulus was 1, then I would be out at this x. But it's not. The modulus now is even smaller. It's about there. This modulus is e to the minus 3 pi over 2 units long. It's quite small. So look at what happened. What happens then is when you have this, we have a spiral in. This is spiraling in, and eventually it will approach. So as we'd say, as y approaches, or not y, as t. So we can say this as t goes to infinity, y of t tends towards 0. This would be a stable graph, a stable solution. And likewise, if our modulus, so if modulus is e to the at, where a is greater than 0, then we have unsteady, and it's a spirals outward, spiral outward. Spirals outward. As a matter of fact, it would spiral out of control. It would explode because E grows so fast. Okay, and that is how the exponential graphs either spirals in or spirals out and travels a path around the circle. I hope that helps, and thanks for watching.